Today we are going to be discuss the chapter Units and Measurements. First of all, we will discuss units. In regular classes, we already studied what are the physical quantities, what are the derived physical quantities, what are the units, derived units, and MKS system, FES system, CGS system, SI units, and so on like that. First of all, let us concentrate what are the SI units. We know that there are the 7 fundamental physical quantities and also 2 supplementary physical quantities. The 7 fundamental physical quantities are mass, length, time, electric current, temperature, light intensity, quantity of matter, and 2 other supplementary quantities are plane angle, solid angle. The units of all these fundamental physical quantities already we know: mass, kilogram, length, meter, time, second, electric current, ampere, temperature, Kelvin, light intensity, candela, quantity of matter, mole, plane angle, radian, and solid angle, stay radian. So all the other physical quantities, or we can say derived physical quantities, are built up with all these fundamental physical quantities. So these will becomes under the SI units. Now let us discuss the dimensional formula of a physical quantity. What is a dimensional formula? It is the expression which shows to what powers the fundamental units or physical quantities are raised in order to obtain the 1 unit of the derived physical quantity. This is called as the dimensional formula. How to write the dimensional formula of physical quantities? So before knowing the dimensions of the, or you can say dimensional formula of the different physical quantities, first of all let us know with what symbols the fundamental quantities are represented. For example, mass. Mass is represented with a symbol capital M, length with a symbol capital L, time with a symbol capital T, temperature with a symbol K or sometimes represented with the theta, electric current represented with a symbol A. So whenever you know all these symbols for the fundamental physical quantities, then easily we can obtain the dimensional formula of different physical quantities. Let us write the dimensional formula of some physical quantities. What mainly we have to know to write the dimensions of the physical quantity or dimensional formula of the physical quantity? First of all, we have to know the unit of the derived physical quantity or the formula for the derived physical quantity. Whenever you know either of that, then easily we can represent the dimensional formula of the physical quantity. For example, velocity is there. The formula for the velocity already know: displacement by time taken. Displacement, it is nothing but length. Symbol for the length already we know capital L. Time, the symbol for the time is equal to already know capital T. Now the dimensional formula of the velocity will become like this: velocity, LT inverse. And clearly you can understand that here there is no presence of the mass term in the dimensional formula of the velocity, m0 lt minus 1. That is, the velocity only depends upon the length as well as the time. It is independent of the mass, that is fundamental physical quantity mass. So this is the easy way to represent the dimensional formula of the velocity. Or if you know the unit for the velocity, then also easily we can write the dimensional formula of the physical quantity. How? You know the velocity unit is equal to meter per second. Meter is the unit for the length, so L. Second is a unit for the time, T inverse. So this is simply called as the dimensional formula of the velocity. And similarly, we can write the dimensional formula of the different physical quantities, and let us check. Let us write the dimensional formula of the different physical quantities. For example, acceleration. Acceleration is equal to rate of change of velocity. Then its dimensional formula simply will become Lt minus 1 by T, that is A is equal to dimensional formula of acceleration is equal to, you will get Lt power minus 2. And of course, the same can be derived by using the unit of the acceleration also. The unit is equal to already you know meter per second square, and the dimensional formula will be comes as Lt power minus 2. And let us write the dimensional formula of the force. You know the formula for the force is equal to what? Ma. Mass, it stands, symbol is equal to capital M. Acceleration dimensional formula, it is nothing but the dimensional formula Lt minus 2. Now the force dimensional formula you will get as Mlt power minus 2, and of course same can be derived by using the unit also. The SI unit of the force already you know Newton, or Newton can be represented as kilogram meter per second square. Don't worry, this is directly we got from the formula F is equal to ma only. The unit of the mass is equal to kilogram and the acceleration unit is equal to meter per second square. And now directly we will write the dimensional formula of the force like this: kilogram, it is the unit of the mass, meter, unit of the length, time, T power minus 2. This is the dimensional formula of the force. And similarly, we can get the dimensional formula of the various physical quantities. Let us discuss few of them. So let me write the dimensional formula of the momentum also. You know the formula is equal to momentum formula. It is a product of mass and velocity. Now the dimensional formula directly will come m, velocity you know Lt minus 1. So momentum dimensional formula is equal to mlt minus 1. Now while writing the dimensional formula of the different physical quantities, we will get some few physical quantities which will have the same kind of the dimensional formula. For example, if I write the dimensional formula of the impulse. Impulse definition already we know, it is a product of the force and time of action of the force. Then how to write the dimensional formula of the impulse? Force already we know, just now we derived mlt minus 2 and time is equal to t, that is simply you will get mlt minus 1. That means when we get the dimensional formula of different physical quantities, we came to understand that few of them are having the same kind of the dimensional formula. So those better to remember. The momentum and also impulse will have the same kind of the dimensional formula. And similarly, we will get the so many other kind of the physical quantities also. Some set of the physical quantities also which are having the same kind of the dimensional formula. Here F is equal to ma. F stands here already we know force. Any kind of the force will be represented with a dimensional formula that is equal to mlt minus 2. Whether it is electrostatic force, magnetostatic force, or we can say centripetal force, centrifugal force, all the forces will have the same kind of the dimensional formula, that is mlt minus 2. And similarly, we will get the different kind of the physical quantity dimensional formula also. Let us discuss few of them again. For example, let us write the dimensional formula of the pressure. Pressure already we know it is the force acting per unit area. So when you know the formula for the physical quantity already we discussed, easily we can write the dimensional formula of the pressure. Then how? Here force is equal to, already we discussed, mLT power minus 2 and area is equal to L square. Now what we get here, simply ml minus 1 T power minus 2, it is the dimensional formula of the pressure. Let us write the dimensional formula of the stress also. How to define the stress? Already we know the definition for the stress. It is the restoring force acting per unit area. Restoring force, already we discussed, any type of the force will be represented with a dimensional formula mLT power minus 2 by L square. And simply the dimensional formula will become ml minus 1 T power minus 2. Now see, the pressure and also stress both are having the same kind of the dimensional formula. And if you write the dimensional formula of the elastic constants, we know that there are three types of the elastic constants we have in the case of the solids: Young's modulus, rigidity modulus and also bulk modulus. The Young's modulus are elastic constant. These are the elastic constant. We know that how to define the elastic constant. It is simply the ratio of stress to strain. And of course, for the Young's modulus, it is the longitudinal stress to the longitudinal strain. Now, stress dimensional formula, just now we discussed, ml minus 1 T power minus 2, strain. You have to know what is the strain. It is simply change in the dimension by original dimension. For example, if you take a wire and when you apply some longitudinal force on it, there will be change in the length. And if you take the ratio of the change in the length to the original length, that gives the longitudinal strain, and it has dimensionless. So simply no dimensions, m0, l0, t power 0, and obviously the dimensional formula Young's modulus, you will get ml minus 1 T power minus 2. So what you understood here, the pressure, stress and all the elastic constants also have the same kind of the dimensional formula. Like this, you will get the some physical quantities which are having the same dimensions. Those you have to remember, which will be very helpful in solving the many problems. And again, let us write the dimensional formula of some physical constants. For example, we have universal gravitational constant capital G. How to write the dimensional formula of the universal gravitational constant? And before that, you have to know the dimensional formula of the at least some physical quantities which are very, very important. Velocity, dimensional formula LT minus 1, force mLT power minus 2, pressure ml minus 1 T power minus 2, acceleration LT power minus 2, and work already you know, it is the force and displacement, dot product of the force and also displacement, and its dimensional formula simply will become ml square T power minus 2. And do remember, the dimensional formula of the work and any type of the energy will have the same kind of the dimensional formula, that is ml square T power minus 2. So minimum you have to remember the dimensional formula of these physical quantities, then easily we can derive the dimensional formula of some other physical quantities which we do not know. Say for example, universal gravitational constant capital G, what is the dimensional formula for that one? So at least we have to know the formula related to the universal gravitational constant, then easily we can derive the dimensional formula. How? So I remember this formula, F is equal to capital G m1 m2 by r square, which is the Newton's universal gravitational law. Or I have one more formula along with me, that is the relation between small g and capital G is equal to capital G capital M by r square. So whenever you use any one of these formulas, then happily we can write the dimensional formula of the universal gravitational constant. How? For example, capital G here we can write Fr square by m1 m2. The dimensional formula of the force is equal to mLT power minus 2. Already we know, we derived that, and R is nothing but here a distance, that is L square. M1 and M2, these are the masses, so we can write M and M. So here 1m will be gets cancelled, then simply you will get m minus 1 L cube T power minus 2. This is the dimensional formula of the universal gravitational constant. And also we can get the same with the help of this formula also. If I write capital G is equal to small g r square by capital M, and small g, we know already that it is the acceleration due to gravity. So acceleration dimensional formula already Lt power minus 2. Now r square is equal to already L square, and mass is equal to m. So m minus 1 L cube T power minus 2. This is the dimensional formula of universal gravitational constant. And next let us write the dimensional formula of the coefficient of viscosity. So coefficient of viscosity, to derive its dimensional formula, at least we have to know one of the formulas related to the coefficient of viscosity. We know that the viscous force acting between any two layers of the fluid, F is equal to eta A into dV by dx, where F is equal to viscous force, eta is equal to coefficient of viscosity, A is equal to area of the liquid layer, dV by dx. This is called as the velocity gradient. Here you see we got one more physical quantity which is called as the velocity gradient dV by dx. Now we can write the dimensional formula of this one simply by knowing the dimensional formula of velocity and also displacement. Velocity, that already Lt minus 1. Here is the distance, it is not displacement. So distance is equal to already L, that is simply you will get T inverse. This is the dimensional formula of velocity gradient. And if you remember the frequency also, what is the frequency? It is the number of oscillations produced per second. That is nothing but reciprocal of the time period. And its dimensional formula also simply will become how much means T inverse. And of course, if you remember the angular velocity also. Angular velocity formula that is 2 pi by capital T. Now omega dimensional formula again will become what? T inverse, where this number do not have any kind of the dimension or dimensional formula. So like this, now presently we have some set of the physical quantities which are having the same dimensions. Like that, while going through the different kind of the physical quantities, we can pick some of them which are having the same dimensional formula or dimensions. Here, eta, coefficient of viscosity, eta is equal to, now we can write F by A into dV by dx. Then how to write the dimensional formula of this one? Simply, force already we know mLT power minus 2, area that is equal to L square, dV by dx. Just now we got that is equal to T inverse. So from this you will get mL minus 1 T power minus 1. It is the dimensional formula of coefficient of viscosity. Like this, you have to remember at least how to derive the dimensional formula of the physical quantities by just remembering the minimum dimensional formula of the minimum physical quantities. This is the way of representation of the dimensional formula of the different physical quantities, and rest of the physical quantities you can try yourself. So before switching to the next topic, let me derive again the dimensional formula of the few physical quantities related to the electricity and magnetism for the sake of easiness. What is the dimensional formula of epsilon naught or epsilon, whatever maybe we call? Epsilon naught means already know it is the permittivity of the free space. Epsilon already know it is the permittivity of the media. Then how to write the dimensional formula of epsilon naught? And also let us write the dimensional formula of the mu naught, or you can say mu. What is the mu naught already? You know mu naught is equal to it is the permeability of the free space, and mu is equal to already know it is the permeability of the medium. Let us write the dimensional formula of the permittivity of the free space or air. So at least you have to know the formula related to the what? Epsilon naught. We know that in electricity, static electricity, the force of attraction or repulsion between any 2 point charges can be represented with the equation 1 by 4 pi epsilon naught q1 q2 by r square, where charges are placed in air or free space. Now by using this formula, simply we can get the dimensional formula of the epsilon naught. How? Epsilon naught comes as q1 q2 by 4 pi f into r square. Now see here, we got the physical quantity charge q1 and also charge q2. 4 pi, however it is a constant, no dimensional formula. F, force dimensional formula, already we know. Distance square, length square, already we know its dimensional formula. Only we don't know the dimensional formula of the charge. Then how to write the dimensional formula of the charge? That can be easily get from the basic definition of the electric current. It is the rate of flow of the charge through the cross section of a conductor. I is equal to q by t. Now charge q is equal to nothing but current into time taken. Now the dimensional formula of the charge simply can be written as I into t. Sometimes it can be present as A into t. Now by using this dimensional formula in this equation, easily we will get the dimensional formula of epsilon naught. How? A into t by 4 pi. However, it is a constant, no dimensional formula. F ml t power minus 2 and distance square, that is L square. Now finally what you get? M power minus 1 L into L square, that is equal to L cube, L power minus 3. This is t square, this comes up, so t power 4 and A into A, that is equal to A square. This is the dimensional formula of the permittivity of the free space or air. And similarly, we can get the dimensional formula of the permeability of the free space or air. How to get that one? So any one relation regarding this mu naught we have to know. You know that in magnetism we already studied that the force of attraction or repulsion between the any two magnetic poles is equal to, you can write as mu naught by 4 pi m1 m2 by r square or d square. Now mu naught is equal to, we can write 4 pi r square f by m1 and m2. However, first of all we have to know what are em1 and em2. Why? Because we know here already force and we know the distance square dimensional formula, but we don't know what are here m1 and m2. But if you remember, m1 and m2 are actually called as the pole strengths of a pole. So what is the unit of the pole strength? Already know it is ampere meter. Already know meter is equal to L. So this is the dimensional formula of pole strength. Now by substituting these values in this, you will get the dimensional formula of the permeability of the free space. Let us see how to get that one. Now I got here mu naught is equal to 4 pi r square f by m1 em2. R square is nothing but L square. This is ml power minus 2. Pole strength AL, that is A square L square. And finally what you get? Mu naught dimensional formula is equal to M 1 L square will be gets cancelled, L t power minus 2 and A square. This is the dimensional formula of the permeability of the free space or air. And like this, we can get the different kind of the physical quantities which are involved in electricity and also magnetism. For example, resistance, ohm, inductance, self-inductance, mutual inductance, and etc. etc. Those dimensional formula also easily we can get just by knowing the any one physical relation. Now let us discuss how to get the dimensional formula of the composite physical quantities. For example, here L by R is there, RC is there, LC is there, E square by 2 epsilon naught HC is there, mu naught epsilon naught is there. Then how to get the dimensional formula of these composite physical quantities? The regular method is, for example, L by R is here taken. The regular method is writing the dimensional formula of the each physical quantity involved in that relation and finding the final dimensional formula. For example, here L is equal to inductance, self-inductance. Already know its unit is equal to ohm second, and R is equal to resistance, its unit is equal to ohm. Now cancelled, directly you will get second is a unit, that is the dimensional formula of L by R is equal to, you will get time t. This is the regular method to find out the dimension of this composite physical quantity. But whenever you know some physical relations, then instead of solving like this, directly we can arrive the dimensions of this physical quantity, that is L by R. How to get that one? If you know the growth of the current in the LR circuit or decay of the current in the LR circuit, we got the one expression like this: I is equal to I naught e power minus t R by L. In this left hand side current is there, so definitely right hand side also must be current must be present, and here exponential functions do not have any kind of the dimensions, and hence this quantity also should become the what? Dimensionless. That is T R by L must be dimensionless, M0 L0 T power 0. Then the dimensional formula of L by R obviously will become how much? Means T. Moreover, if you recall the knowledge, this is nothing but the time constant of the LR circuit. So this is the easiest way to represent the dimensional formula of the L by R. And similarly, let us get the dimensional formula of RC. Again, the standard way already you know how to find out the dimensional formula, finding the dimensional formula of the each quantity. How? Here resistance is there. Resistance formula I know R is equal to V by I here, and capacity already know, that is equal to C is equal to Q by V. V gets cancelled. Current is equal to nothing but charge by time, that is 1 by Q by time into Q. Q will be gets cancelled, and again you will get the time, that is the dimensional formula of RC is equal to, you are going to be get what? Means time t. But again, if you recall the knowledge regarding this RC circuit, DC circuit, the growth of the charge or decay of the charge can be represented like this. The decay of the charge, Q is equal to Q naught e power minus t by RC. So obviously again this should be dimensionless. To become this dimensionless, then RC dimensional formula must be is equal to what? Means time. And again this is the time constant of the RC circuit. And similarly we can get the dimensional formula of the LC as well as the dimensional formula of E square by 2 epsilon naught HC and also mu naught epsilon naught. Let us get that. Let us get the dimensional formula of LC. And again, One our ordinary method is writing the dimensional formula of each physical quantity in that expression. But I will tell one more method here to find the dimensional formula of the LC. I think the LC oscillator, we already studied the frequency of the LC oscillator f is nothing but equal to 1 by 2 pi root LC. Now using this equation, simply we can find out the dimensional formula of the LC. How? Take that side root LC, that is equal to 1 by 2 pi f. But you know frequency is equal to what? Means 1 by t. That is root LC is equal to nothing but t by 2 pi. Square LC dimensional formula is equal to nothing but t square. Like that easily we can represent the dimensional formula of the LC without substituting the dimensional formula of the individual physical quantities. And if you observe this relation, E square by 2 epsilon naught Hc. And how to write the dimensional formula of this one? Very simple. And if you have any idea about the atoms topic, in that we already discussed that the velocity of the electron in the nth orbit can be represented as like this, alpha c by n, where alpha is actually called as the fine structure constant, dimensionless constant, that is fine structure constant. That value is equal to how much? Means E square by 2 epsilon naught Hc. So whenever you have that knowledge, E square by 2 epsilon naught Hc is equal to a fine structure constant, then instead of substituting all the dimensional formula of these individual physical constant and arriving at the final dimensional formula, then simply we can write that it is a dimensionless constant. So you must have the idea about the different relations also. And similarly, what is the dimensional formula of mu naught and epsilon naught? How to write this one? One of the method is what? Means substituting the dimensional formula of each physical quantity here and arriving the relation. But other method is, you know, in electromagnetic waves already have studied that the velocity of the light is equal to, can be represented as root of mu naught and epsilon naught, reciprocal of root of mu naught and epsilon naught. If you know this relation, then easily we can get the dimensional formula of that equation. How? Simply on cross multiplication you will get root mu naught epsilon naught is equal to 1 by c. Squaring this, mu naught epsilon naught is equal to 1 by c square, which is nothing but velocity dimensional formula already you know, L t minus 1, that is equal to whole square, that is whole square, and finally you will get as L power minus 2 and also t square. It is the dimensional formula of mu naught epsilon naught. So like this we can get the dimensional formula of the various physical quantities involved in different situations. Next we will go through the important concepts, the applications of the dimensional analysis and also principle of homogeneity. Let us discuss the principle of homogeneity. What is the principle of homogeneity? According to this, the physical quantities having the same dimension always can be compared, equated, subtracted. So this is the principle of the homogeneity. Basing on this principle of homogeneity, it is possible to us to find out the dimensional formula of the different physical quantities involved in different situations or equations. Let us try to find out the dimensional formula of the different physical quantities and also constants which are involved in the different equations. Now basing on the principle of homogeneity, let us get the dimensional formula of the different constants involved in this equation. Say here equation is represented as V is equal to AT plus BT by C minus X plus CT square by X. Here V is represented as velocity, T is as the time, X is equal to distance, and here A, B, C are the constants. I'll do one thing here. Instead of taking C here, I will take the new physical quantity, say D. Now let us get the dimensional formula of A, B, C and also D. How to get the dimensional formula of A, B, C, D? Now we already studied principle of homogeneity. According to this, like physical quantities, or you can say physical quantities having the same dimension always must be added, subtracted, compared or equated. That is, from the velocity, only velocity will be subtracted. We cannot subtract the force. That means velocity and also velocity are the physical quantities are having the same dimensions. Based on this concept, let us get the dimensions of A, B, C, D here. For example, left hand side velocity is there and the right hand side there are the sum of the three relations AT, BT by C minus X, dt square by X. As left hand side velocity is there, so right hand side also. Why? Because according to the principle of homogeneity, equal physical quantities are like physical quantities, or physical quantities having same dimensions must be equated. So left hand side velocity is there, so right hand side also must be velocity present. So here, and moreover in the right hand side, this is the sum of the three terms. So definitely these three terms also should be velocity. Why? Because same kind of the physical quantities are added. ఒకే రకమైన ఫిజికల్ క్వాంటిటీస్ మనం యాడ్ చేయాలి కాబట్టి లెఫ్ట్ హ్యాండ్ సైడ్ వెలాసిటీ ఉంది కాబట్టి రైట్ హ్యాండ్ సైడ్ కూడా ఖచ్చితంగా ఈ త్రీ ఫిజికల్ రిలేషన్స్ కూడా వెలాసిటీ అయి ఉండాలి. సో నౌ లెట్ us get that one. Velocity should be AT. Why? Because both are same. Left hand side must be is equal to right hand side, and velocity must be is equal to BT by C minus X, and velocity must be is equal to dt square by X. And using this relation, easily we can get the dimensional formula of the constant A. How? Velocity LT minus 1 A into time is equal to T. From this A dimensional formula you will get as LT minus 1, T goes that side, so you will get LT minus 2. Similarly here, in this relation we have to understand one more important thing here, that we are subtracting something from the displacement or distance. Why? Because x is represented as a distance, or you can say displacement like that. Displacement is going to be subtracted from the C. So according to the principle of homogeneity, this also should be what? Displacement. That means the dimensional formula of the simply we can write as what means L. Now let us write the dimensional formula of B. Now velocity, that is LT minus 1 left hand side, and right hand side B we have to find out. T is equal to time, and this is the already we called as distance, and this is also distance, and on subtraction again you will get the what means distance. Now B is equal to, that is dimensional formula of B is equal to, you will get L square T power minus 2. So we got the dimensions of A, dimensions of C, dimensions of B, and next one is what? D. Now left hand side velocity is there, so LT minus 1, this is D, and time square, this is the distance L. Now D dimensional formula you will get as L square T power minus 3. So this is a way of representing the dimensional formula of the different physical quantities involved in this equation basing on the principle of homogeneity. And of course we can write the units of these constants also. How to write the units? Very simple. Length, meter, time, meter per second square. And how to write the unit of the C here? Length, that is equal to nothing but what? Meter. And B, unit, this is length square, that is meter square per second square. And what is this one? Meter square per second cube. And like that we can write the dimensions as well as the dimensional formula as well as the units of the physical constants also in this equation. Now next let us check this relation, F is equal to A by T plus BT square. Here F is the force and T is the time. We don't know what are the units of this A and also B. A is the constant, B is the constant. And according to the principle of homogeneity, we already discussed that the physical quantities having the same dimension always must be compared, equated, added, subtracted. ఒకే రకమైన డైమెన్షనల్ ఫార్ములా కలిగి ఉన్న ఫిజికల్ క్వాంటిటీస్ని ఈక్వల్ చేయాలి కాబట్టి లెఫ్ట్ హ్యాండ్ సైడ్ ఫోర్స్ ఉంది, రైట్ హ్యాండ్ సైడ్ ఇట్ ఈస్ ద సమ్ ఆఫ్ A by T and also BT square. So force dimensional formula must be is equal to the dimensional formula of A by T, and force dimensional formula must be is equal to dimensional formula of BT square. Now easily we will get the dimensional formula of A. How? From this equation, F already you know, mLT power minus 2, A by this is the time. Now A is equal to, you will get mLT power minus 1. This is the dimensional formula of A. And from this F is equal to mLT power minus 2, already you know, and B is constant, T square, that is B dimensional formula is equal to, you will get mLT power minus 4. This is the usage of the principle of homogeneity. A very important equation, van der Waals equation, already you know. In that what are the dimensions of constant? Here P is equal to, already you know, pressure, V is equal to volume, T is equal to temperature, R is equal to universal gas constant. Here you will be asked to find out the dimensions of A, B, and also what is the dimensions of A by B. How to get? And again here we will make use of the principle of homogeneity. We are adding something to the pressure. So already we discussed that the physical quantities having the same dimension always will be added. So if P is the pressure, then definitely A by V square also should be pressure. And similarly here also something is subtracting from the value. So this something also should be represented what means value. Now basing on this concept, easily we can find out the dimensional formula of A and also B. How? Here you see the dimensional formula of P must be is equal to A by V square. Dimensional formula of the pressure, already you know, ml minus 1 T power minus 2. In case you do not remember, if you know the formula, pressure is equal to force per unit area, from that easily we can get, and that is equal to A by volume meter cube, that is L cube. Now dimensional formula of A is equal to, you will get m, this is V square is there, so this also should be square. Now m, this will get L power 5 T power minus 2. This is the dimensional formula of A. And the next, the dimensional formula of B. That B also must be value. Why? Because we are subtracting B from the value. Now B dimensional formula is equal to, will get how much means L cube. Now you are asked to find out the dimensions of A by B also, dimensional formula of A by B. A is equal to ml power 5 T power minus 2 by, this is L cube. This you will get as ml square T power minus 2. So the dimensions of dimensional formula of A by B is equal to ml square T power minus 2. Can you recall which physical quantity will have the same dimensional formula ml square T power minus 2? Already you know it is a dimensional formula of what means work or energy or torque. So this A by B may be belong to the work or energy or torque. So like this, by using the principle of homogeneity, we can find out the dimensional formula of different physical constants involved in the relations. Next we will discuss the dimensional analysis, usage of the dimensional analysis. Next we will discuss the dimensional analysis and what are the advantages of the dimensions. The advantages of the dimensions or dimensional formula are: number 1, conversion of the unit of a physical quantity from one system to the other system, and the second usage is checking the correctness of the given equation, and the third one is getting the formula related to the different physical quantities. Now let us discuss one by one. The first one is converting the unit of the physical quantity from one system to the other system. If you take the measurement of a physical quantity, measurement. For example, if I take the length of a rod, say that is equal to 2 meters. That means in this measurement you will get the one numerical value along with the what? Unit, n into u. So this is always a measurement must have. N is equal to numerical value and also u is equal to unit. I can express same 2 meter measurement in another system, that is in CGS system. 1 meter is equal to already know 100 centimeter, that is equal to you will get 200 centimeters. Now compare these two values. This is the meter is the unit in the SI and centimeter is a unit in CGS, and we got here numerical value in SI units is equal to here 2, and whereas here we got the what means 200. Now basing on this concept, easily we can convert the unit of any physical quantity from one system to the other. How? For example, here we are going to be prove that 1 Newton is equal to 10 to the power of 5 dyne, where Newton is the unit of the force in SI units and dyne is the unit of the force in CGS units. Then how to get this relation? 1 Newton is equal to 10 to the power of 5 dyne force. You know that 1 Newton simply can be represented as kilogram meter per second square. How? You know the formula F is equal to what? MN. So basing on that, kilogram m meter per second square acceleration. Now how to convert into CGS units? You already know that 1 kilogram is equal to nothing but 1000 grams, and 1 meter is equal to nothing but 100 centimeter, and second square in CGS units also second unit of the time is second only. Now from this what you get? 10 to the power of 5 gram centimeter per second square. Now this gram centimeter per second square is called as the dyne. So 1 Newton is equal to, simply we can write 10 to the power of 5 dyne. Like this we can convert any one of the unit from one system to the other system. Similarly, how to get 1 joule is equal to 10 to the power of 7 erg. 1 joule. Joule is a unit for the work. Work is equal to already know F bar dot S bar, or the dot product of force and also displacement. Here force unit is equal to already know Newton, displacement unit is equal to already know meter. This Newton meter simply represented in SI units as joule. Now 1 joule is equal to 1 Newton into 1 meter. 1 Newton is equal to already know 10 to the power of 5 dyne. 1 meter is equal to already know 100 centimeter. From this easily we will get 10 to the power of 7 dyne centimeter. Dyne centimeter is called as the erg, so 10 to the power of 7 erg. Like that we can convert the unit of the any physical quantity from one system to the other system. In the previous two examples, here we know one is the SI unit and other one is the CGS unit. If you would like to convert any one physical quantity unit from known unit to unknown unit, then how to find out that one? Let us discuss that. Here we know that the acceleration due to gravity value is equal to 9.8 meter per second square in SI units. But here what I would like to do, I am going to be designing a new system in which I am going to be take the unit of the length is kilometer and the unit of the time as minute. If I take the unit of the length as kilometer and the unit of the time as unit, then how to get this value in this new system? So again, this will be also very easy to find out. The one of the basic method is like this: N1 U1 is equal to N2 U2. Why? Because the measurement of a physical quantity should not be changed even you convert into different kind of the systems. Here N1 U1 is equal to N2 U2. Let it be U1 is equal to what? SI unit, and U2 is equal to some new unit. That is, here I would like to find out N1 meter per second square into what? N2 kilometer per minute square. You know that N1 is equal to nothing but N1. The dimensional formula of the meter per second square, that is acceleration due to gravity, LT minus 2. It is in the SI unit, so L1 T1 is equal to N2. Now it is in new units, so let me call L2 and T2 power minus 2. Then N1 is equal to, we can write N2 into L2 by L1 and T2 by T1 power minus 2. N2. L2 by L1. L2 is what here? L2 is the unit of the distance in new system, that is equal to kilometer. 1 kilometer is equal to already 1000 meter. L1 is what? L1 is a unit of the length in SI unit, that is equal to meter. T2 is what here? T2 is a unit of the time in new system, that is minute. Minute is equal to already 60 seconds by T1. T1 is a unit of the time in SI unit, that is equal to second, power minus 2, meter. And N1 is equal to, you will get N2 into 1000 into, no need of writing this bracket, 1000 into, this is 60 power minus 2, means you can write this is 1 by 60 into 60, zeros will be gets cancelled, then you will get 10 by 36. Let me call this is the equation number 1, this is the equation number 2. So in the equation number 1, what you wrote here? N1 meter per second square is equal to N2 kilometer per minute square. Now I can write N1 is equal to is nothing but N2 into 10 by 36. Meter per second square is equal to N2 kilometer per minute square. N2 will be gets cancelled. 10 meter per second square is equal to 36 kilometer per minute square, or 1 meter per second square is equal to 36 by 10 kilometer per minute square. We require to find out 9.8 meter per second square. Multiply both sides with 9.8. 9.8 into 36 by 10 kilometer per minute square. If we take approximately 9.8 as 10, both will be gets cancelled. That is, you will get 36 kilometer per minute square. So this is the way of conversion of the any one unit from known system to the another new system. Same also we can easily derive by using the simple relation also like this. G is equal to, we know that 9.8 meter per second square. In the new units, 1 kilometer is equal to 1000 meter, or 1 meter is equal to kilometer by 1000. And similarly, 1 minute is equal to 60 seconds, or 1 second is equal to 1 minute by 60. Substitute directly that value in this equation. 9.8 into meter is equal to nothing but kilometer by 1000 into second square, that is 1 by second square, means you can write minute by 60 whole square, that is 9.8 into, you will get 3600 by 1000 kilometer per minute square. So on simplification, you will get, if 9.8 is taken as approximately 10, so you will get 9.8 meter per second square is equal to is nothing but 36 kilometer per minute square. So like this, we can convert the unit of any one physical quantity from one system to some unknown system also. Okay friends, the next two uses of this dimension analysis we will discuss in the next class. The two uses already we know, correctness of the given equation and also getting the relations among the different physical quantities.